Okay, let's start with thermo exemplar solutions. As always, if you want to look at the theory sessions, go to bento.me/iteachchem and you can check out all of that. Here, हम लोग देखेंगे कि टेस्ट टेकिंग की टिप्स और ट्रिक्स कैसे हों. And we're going to solve exemplar questions. Thermodynamics is not concerned about energy changes. It is, I think it is concerned about energy changes. So is not the answer. Extent to which chemical reaction proceeds. Interesting. Extent to which, okay, I'm going to keep that aside. देखते हैं इसका क्या करेंगे. The rate at which, yeah, definitely not. Definitely not. Rate, हम लोग time की तो बात करते ही नहीं है, right? So rate is not. So this is the most likely answer. Feasibility of a chemical reaction, yeah, spontaneity, etc. सही, hence wrong. Extent to which a chemical reaction proceeds. That's interesting. Technically speaking, ये जो extent वाली बात है, ये तो आप लोग कहाँ देखते हैं? You see it in equilibrium, not really in thermo, is my take. But यहाँ पे ज़्यादा relevant answer ये वाला तीसरा वाला है, rate. So we'll mark that and move on. Which of the following statements is correct? Not correct पहला वाला था, this one's not correct. This one is correct. Presence of reacting species in a covered beaker is an example of open system. Covered beaker, open, ये क्या हो रहा है? Anyway, there's an exchange of energy as well as matter between system and surrounding in a closed system. नहीं, that's the definition of an open system. अजीब सवाल है भाई, बहुत simple है. The presence of reactants in a closed vessel made up of copper is an example of a closed system. Yeah, this is the easy one. मुझे तो यही लग रहा है आंसर. Presence of reactants in a thermos flask or any other closed insulated vessel is an example of a closed system. Now, मेरे हिसाब से ये भी सही है. Think about it. A closed system is a subset of an insulated system, isn't it? Rather, other way around. Sorry, मैंने maths गलत बोला, but भावना को समझिए. If this is insulated and this is closed, all insulated systems are closed systems, right? But all closed systems need not be insulated. That's what I'm trying to say. And sure, open is on the other side if you like Venn diagrams. तो ये option 4 kind of weird है, but again, option 3 is what stands out and is definitely the answer. Let's move on. The state of a gas can be described by quoting relationship between PVT. Be careful. There's also amount of stuff. This is the answer. जल्दी में मत mark करना. The volume of gas is reduced to half its original volume. Specific heat volume से क्यों नहीं बदलेगी? It's an extensive property. No, it's intensive property. Extensive properties are those that, well, depend on number of particles, right? Intensive do not. And intensive, and यहाँ पे तो number of particles की भी बात नहीं हो रही है. You're literally just volume of gas को कम कर रहे हो. So intensive properties are not going to change because of all of this. Khair, let's move on to the next one. During complete combustion of 1 mole of butane, इतनी heat release हो रही है. Oh, 1 mole of butane. So let's scratch this out because इसमें 2 mole है. 1 mole could be this, this or this. Okay, कुछ reaction ऐसा balance लग रहा है. What's the difference? अच्छा, ये number, is it plus or minus? Let's remove this, it's not in the picture. 2658 is released. Released यानी कि, okay. Because H of reactants is lower than H of products, right? If I were to write that here on this sort of an energy diagram, this is reactant, this is product. और इसका जो फर्क है, this is the energy released. समझ रहे हैं? You see where I'm going with this? If this is the energy released, what does this mean? That delta H reaction is going to be negative. थोड़ा सा theory भी हमने कर ही लिया. But yeah, the answer because of this logic is 3. Delta U formation of CH4 at certain temperature कुछ दिया हुआ है. What is this? You see graphite, है ना? लिख ही लेते हैं. Because you have to compare delta HF and delta UF. Plus 2H2, which is gas, gives you 1 mole of CH4, which is also a gas. Now, what was the definition? H is U plus RT. Actually, specifically it was PV, right? And then we said, oh, you know what, बहुत चीज़ें होती है. But anyway, delta H is delta U plus delta NG RT. Number of moles of gas. Delta NG is going to be equal to 1 minus 2, which is equal to negative 1. This is 1, this is 2. And हम लोग इसी की बात यहाँ पे कर रहे हैं. ठीक है. What does this imply? This implies that delta H is going to be lower than delta U. Logical चीज़ है, if a question like this comes, please don't skip it. ठीक है, ये theory आप पढ़िए. This is what thermo is all about, all this logic, right? Okay, 7th question. In an adiabatic process, no transfer of heat takes place between system and surrounding. क्यों? क्योंकि wall होती है adiabat, right? The wall is what does not allow heat to go through. Anyway, choose the correct option for free expansion. Oh, free expansion मतलब external pressure is zero. You're not exerting any pressure, right, for it to expand against. जिसके कारण you know what's happening here, right? Work is going to be equal to zero. Also, because adiabat है तो Q is zero and work is zero. So this option can be eliminated, right? Q is 0, work is 0. Yeah. So the only options are 3 and 1. Q or W तो 0 है. What about change in temperature? Well, if you want to look at it like this, delta U is Q plus W. अगर यही दोनों चीज़ें 0 हैं तो delta U also is 0 and delta U is NCV delta T. तो सिर्फ ये हो जाएगा 0, right? Which means T is constant. Hence this is the answer. This is just math, isn't it? ये तो हम लोग algebra कर रहे हैं, looks like, with some logic. The PV work of an ideal gas calculate कर सकते हैं इस expression से, ठीक है? Okay. Work हम लोग PV plot से भी निकाल सकते हैं. अब using the area under the curve within limits, ideal gas जब compress होती है दो चीज़ों से, या तो reversibly या irreversibly from VI to VF. VF मतलब has to be lower than VI, right? Compression हो रहा है. तो if I mark VI over here and VF over here, ये समझ में आ रहा है ना? कंप्रेस कर रहे हैं हम लोग, ठीक है, एंड प्रेशर इधर होगा. कंप्रेस कर रहे हैं मतलब फाइनल प्रेशर हाई होगा, राइट? इनिशियल प्रेशर लो होगा. सो दिस इज गोइंग टू बी पीएफ, दिस इज गोइंग टू बी पीआई, ठीक है? ओके, हमको ग्राफ की जरूरत पड़ेगी यहाँ पे. दिस माइट टेक अ लिटिल बिट ऑफ टाइम एंड दिस इज एन इंटरेस्टिंग क्वेश्चन. डायरेक्ट थियरी भी है, अगर आपको याद है. नहीं याद है तो वी कैन फिगर इट आउट ऑन द फ्लाई, नो बिग डील. नाउ वी हैव टू फिगर आउट वर्क रिवर्सिबल वर्सेस इरिवर्सिबल कैसा होता है. Now, reversible work can be plotted on a graph. ठीक है? This is reversible work. I'm going to use some other color here to show you irreversible work. Okay. Now, this, let's go back to that blue 1 minute. Yeah. So if I were to do this, this is the area under the curve, etc., etc. जो भी है, but you can also use your expression, right? What was your expression? You could do this. What was it called? मैं डायरेक्शन यहाँ से दिखा रहा हूँ कि यहाँ से इस जो गोइंग फ्रॉम VI टू VF. ओके, यू हैड U माइनस N RT ln whatever जो आप इंटीग्रेट करते थे, राइट? दैट गिव्स यू द वर्क डन ओवर हियर इन दिस केस. ओके, दैट्स रिवर्सिबल. व्हाट अबाउट इररिवर्सिबल? इररिवर्सिबल प्रोसेसेस, पहली बात तो आप प्लॉट कर नहीं सकते हैं ग्राफ पे, ठीक है? बट यू कैन स्टिल यूज दिस आइडिया टू फिगर आउट व्हाट इज द वर्क डन. If it is one single step, एक step में हो रहा है. So initially gas is here. I'm doing a little bit of theory here, I know. यहाँ पे final pressure है, and gas is being compressed against some external pressure, right? Against P external. Now what is the external pressure? In this case is the final pressure itself. So this is what the volume. This is what the PV curve is going to look like, right? And this is the extra work that's going to have to be done if it is done in one step. अगर आप 2 steps में करेंगे, let me erase this. Step 1 is this, where this is P, say 2, right? And then this is the other step. So this is the extra work being done. So in all cases, you can see if you keep increasing the steps, basically it tries and gets back to the reversible idea itself. What am I trying to say? You can very clearly see कि सब केसेस में irreversible work is greater than reversible work when you are compressing the gas. ठीक है, ये compression में होता है. और उल्टा होता है exactly in expansion. I've done this in theory a lot and I probably really like it. This is why I went into so much detail talking about this. I didn't need to, but here you go. This is the answer to this. Okay. The entropy change can be calculated by using this expression. Delta S is Q reversible by T. जब पानी फ्रीज होता है तो क्या होता है? जब पानी फ्रीज होता है, ओके, So I've got, well, H2O liquid becoming H2O gas. नहीं, solid. मैंने डबल हेड एरो से डाली क्योंकि थियोरेटिकली रिवर्सिबल है, बट ठीक है. वी आर सेइंग दैट इज गोइंग इन दिस डायरेक्शन. ओके, इस डायरेक्शन में जाने के लिए क्या करना पड़ेगा? आई हैव टू रिमूव हीट फ्रॉम द सिस्टम, राइट, विच मीन्स दैट दिस इज गोइंग टू बी एन एक्सोथर्मिक प्रोसेस, है ना. मैं जब इससे हीट निकालूंगा तभी ये प्रोसेस इस डायरेक्शन में जाएगा, राइट, विच मीन्स दैट Q is negative and it's QP specifically, right, क्योंकि प्रेशर कांस्टेंट पे हम लोग कर रहे हैं. एंड QP जो आपका सराउंडिंग का है दैट इज गोइंग टू बी पॉजिटिव. क्यों? क्योंकि ये हीट जो जा रही है वो कहाँ जाएगी? सराउंडिंग में ही तो जाएगी. दिस इज सिस्टम. हाँ, सिस्टम सराउंडिंग का आइडिया क्लियर होना बहुत ज़रूरी है. दैट इज बेसिकली डिफाइंड बाय अ बाउंड्री, राइट. बाउंड्री के अंदर जो सिस्टम, बाउंड्री के बाहर सराउंडिंग. एवरीथिंग दैट्स नॉट द सिस्टम इज सराउंडिंग, एटसेट्रा एटसेट्रा. ठीक है. नाउ लुकिंग एट दिस यू विल क्लियरली सी कि एंट्रोपी कम हो जाएगी फॉर सिस्टम एंड फॉर सराउंडिंग बढ़ जाएगी. दैट्स इट. दैट्स द आंसर. डेल्टा एस सिस्टम डिक्रीजेस, नॉट द सेम, डिक्रीजेस एंड इंक्रीजेस. सराउंडिंग इंक्रीज होती है. अनदर कूल थियोरेटिकल क्वेश्चन जिसमें आपके कॉन्सेप्ट्स को बिल्कुल क्लियर होना ज़रूरी है टू बी एबल टू फिगर इट आउट. आई लाइक दिस. मज़ेदार सवाल है थर्मो में, एनसीईआरटी में. ऑन द बेसिस ऑफ थर्मोकेमिकल इक्वेशंस 3 दी हुई हैं. आपको फिगर आउट करना है कौन सी एल्जेब्रिक एक्सप्रेशन इसमें से सही ऑप्शन होगा. ये काफ़ी स्ट्रेट फॉरवर्ड सवाल है थर्मोकेमिस्ट्री का. व्हाट्स हैपनिंग हियर? यू हैव CO2 ऑन द राइट हैंड साइड हियर, यू हैव CO2 ओवर हियर. अच्छा, ठीक है. मतलब कि x और z इक्वेशन के दो अलग साइड में होंगे. इसका मतलब क्या हुआ? इफ यू एबल टू कैच ऑन दिस ग्रेट, इफ नॉट डोंट वरी. दिस इज वन क्विक वे ऑफ डूइंग इट, राइट. अगर इफ आई पुट x एंड z ऑन डिफरेंट साइड्स एंड विद अ पॉजिटिव साइन, उसी से आई एम एबल टू एलिमिनेट दिस एंड एलिमिनेट दिस, बिकॉज ये 2z है नॉट z, राइट. ये CO2 एक ही इसका नंबर होगा. सो आई एम लेफ्ट विथ, है दीज टू लुक सिमिलर. अच्छा नहीं, 1 and 3 में थोड़ा तो फर्क है, राइट. 3 में आई हैव x इज y प्लस z और दूसरी जगह x इज z माइनस y हो जाएगा अगर आप 1 को देखेंगे. ठीक है. तो अभी नाउ वी कांट जस्ट हैक थ्रू, जिसको भी थोड़ा एफर्ट लगाना पड़ेगा. ठीक है, कर लेते हैं, क्या फ़र्क पड़ता है. नाउ इफ़ यू जस्ट लुक एट दिस, यहाँ पे CO इस तरफ है, CO इस तरफ है. यानी कि इफ आई ऐड बोथ ऑफ दीज रिएक्शंस एंड हेंस द z एंड y वैल्यूज, व्हाट हैपेंस इज CO कैंसिल हो गया, ये दोनों ऐड हो जाता है, एंड देन यू गेट बैक दिस इक्वेशन. सो दिस इज द ईजियर वे ऑफ डूइंग इट इन दिस केस. दिस इज योर आंसर. कौन सा ऑप्शन है ये? Option 3. I like thermo. Do you like it? I know some students find this to be a little difficult, but you can see काफ़ी direct और आसान है भाई. Consider the reactions given below. On the basis of these reactions, find out which of the algebraic relations given in options 1 to 4 is correct. This one's interesting. यहाँ पे क्या हो रहा है? Carbon gas reacts with 4 अलग-अलग H atoms to give you CH4. तो यहाँ पे bonds are being formed. Right? What about this second expression, second equation? पहले you've got graphite and then you have to get it to C gas. You have to sublimate this. Okay? You've got this and then you have to get it to 4H. मतलब enthalpy of atomization is going to come to picture. And then you're going to get to this. Looks like ये जो option A है वो एक subset है B का. मतलब B के अंदर ही वो A आ जाता है. What do I mean? यहाँ पे bonds are breaking. And कौन से bonds are breaking? You see this, right? I'm breaking bonds here by going this direction of ये जो molecule है H2 का, उसको break करके we're making it atoms, right? And graphite को भी हम लोग sublimate कर रहे हैं, तो उसको energy आपको देनी पड़ेगी, energy input, right? So that's plus. And bonds form मतलब कि energy released, okay? तो यहाँ कुछ bonds form हुए, and there's also this, ये भी आएगा picture में, right? This plus this will eventually lead to B. अब इस पूरी राम कहानी का मतलब क्या है? मतलब ये है कि this is only negative and let's say this is say minus B, right? and ये हो जाएगा A minus B. मतलब कि अब क्या करें? Now it depends on whether A is positive, I mean A की value क्या है, but whatever value it is reducing इसकी वैल्यू इन टर्म्स ऑफ द न्यूमेरिकल वैल्यू, राइट, अगर मैं इसको लेता हूँ, लेट्स टेक इट एज 10 and 5 रैंडम नंबर, -10 + 5, तो ये -10 को कम करके -5 कर रहा है. दैट इज वॉट B इज गोइंग टू बी, राइट. वॉट इफ आई टेक इट व्हाट इफ आई टेक इट -5 and +10, फिर भी वो -5 को जो है it is increasing that value and it's becoming +5, and then that's what makes it interesting. अरे अब पर इन दोनों केस में you can clearly see that this value is basically y, right? यहाँ पे है y और यहाँ पे लेफ्ट साइड में है -10 -5, ये है x. दोनों केसेस में doesn't matter whether value is positive or negative, just to prove to you, दोनों केसेस में y is greater than x. That's it, simple maths. Answer is 4. And for some reason NCERT says that इसमें इसका आंसर है 3 and they've given justification and all that. खैर, to make sure there is no confusion whatsoever, I've put some numbers to this, right? And I've taken both cases. यही तो दोनों केस हो सकते हैं ना, एक पॉजिटिव एक नेगेटिव, क्या ही होगा, एक छोटा और एक बड़ा होगा. पॉजिटिव नेगेटिव तो नो कन्फ्यूजन देयर, राइट, बिकॉज द आइडिया इज दैट दिस वैल्यू, ये जो a है, राइट, which is some positive value that has to be there to break these bonds. कौन से bond? Graphite to carbon gas, which is sublimation, and also atomization risk. ये दोनों positive values है, इसलिए मैंने यहाँ पे ये लिखा है. Just so that it's easy to understand, I'm going to put this color code here. So this is, ये जो +5 +10 है, this is the bond breaking वाली चीज़, ठीक है, accounting for that. Just to prove to you y is always greater than x, nothing else happens. ठीक है, again thermo seems to be just completely maths. Let's move on to the next one. The enthalpies of elements in their standard states is always taken as 0. All right, sure, are taken as 0. You know, मैंने always बोल दिया, but ठीक है. The enthalpy of formation of a compound हमेशा negative होता है क्या? Well, if you've seen my theory sessions, you'll know that's not the case. It could be positive or negative. Take simple example of N2 + O2, दोनों है gases, giving you NO. Right? This is a famous example. What you're doing here, well, ठीक है, इसको half कर देते हैं because enthalpy of formation and all. You are breaking bonds again and then forming new ones, right? So it depends on the magnitude, कितना आप break कर रहे हैं, कितना कर रहे हैं. This whole overall delta H can be positive or negative. Now, just like ऊपर मैंने आपको दिखाया, right? In this case पूरा delta H negative था, इस case पूरा delta ये पूरा डेल्टा एच विल बी, क्या बोलते हैं, पॉजिटिव, बट या सेम आइडिया हियर. तो बेस्ट जस्ट डन बिकॉज हमने जस्ट अभी इसको पुराना वाला देखा था, तो ये वाला सिंपल होना चाहिए. बट इवन विदाउट दिस ये आपको समझने में ज़रूरी है. डोंट मग थिंग्स रैंडमली कि अरे फॉर्मेशन हमेशा नेगेटिव होगा. ठीक है, थोड़ा सा ध्यान से पढ़िए थर्मो. दैट्स व्हाट मेक्स इट टफ. अगर ध्यान से नहीं पढ़ेंगे देन इट्स हार्ड, अदरवाइज वेरी कूल चैप्टर. ओके, एंथैल्पी ऑफ सब्लिमेशन ऑफ अ सब्सटेंस. हाँ, ये तो यही है. सब्लिमेशन हम लोग क्या करते हैं? यू हैव अ सॉलिड दैट बिकम्स अ लिक्विड दैट बिकम्स अ गैस. I mean, in some cases like camphor, you may skip the liquid state, but you're basically doing both of this. ये है enthalpy of fusion, ये है vaporization, है ना? तो इसलिए पहला आंसर सही है. दोनों चीज़ें हैं, not just one or the other. You can get confused because hey, sublimation मतलब this is a direct consequence of the fact that delta H is a state function, right? 1 step करो, 10 steps करो, it's the same value. That's it. Okay, which of the following is not correct? Delta G 0 for reversible reaction. Delta G is 0 for a reversible reaction. Huh, that's a weird thing to say. Delta G is 0 for a reversible reaction. Delta G is 0 at equilibrium. I don't know. Why would it be 0 for a reversible reaction? I feel यही गलत है. खैर, delta G is positive for a spontaneous reaction. ये भी गलत है ना? Delta G is 0 for reversible reaction doesn't make sense, right? Delta G could be positive or negative, and you have reactions that still go to equilibrium. At that equilibrium point, delta G is 0. I agree there, right? But पहला वाला statement मुझे अजीब लग रहा है. Maybe this is a misprint or some weird thing. But answer जो आपके NCERT में दिया is 2, which is clear कि delta G must be negative for a spontaneous process, which is right. Hence not the answer. Last option देखते हैं. Delta G is positive for a non-spontaneous reaction. ये भी सही है. Hence not the answer. Okay, more than one correct. Question 15. Thermo deals with interrelation of various forms of energy and they're transformed from one from one to another. बढ़िया. Energy changes in the process depend only on initial final states of the microscopic systems containing a few molecules. Wow, what? Why? Firstly, it's with a lot of molecules, right? Statistical thermodynamics. Not something जो आप लोग पढ़ रहे होंगे, but anyway, that's why this one's wrong. There are many other ideas, but इसकी वजह से तो पक्का ये गलत है. How and what rate? No, we don't talk about rate. We don't talk about time. Rate is something that changes with time. We don't talk about time in thermodynamics. The system in equilibrium state or moving from one equilibrium state to another equilibrium state. Sure, I give things enough time. Things don't change with time. And then let's go to another quarter. This is one state. Then you go to another state where you give it enough time to reach quote unquote equilibrium until you get there. So ये वाला भी सही है. Yeah, 1 and 4 according to me. 16th one. In an exothermic reaction, heat is evolved and system loses heat to surrounding for such a system. Okay, exothermic reaction. Matlab Q is negative. Okay, and delta H is also negative. Well, yeah, what is QP anyway? QP is delta H, but that's not what we're talking about here. Heat is evolved and system loses heat to surrounding. System heat is, अच्छा मतलब हाँ, तो Q surrounding is positive, Q system is negative. Okay, I think we are good. QP, funny options. QP and delta H, right? Same ही तो है. 16 is 1 and 2, right? What about 17? The spontaneity means having the potential to proceed without the assistance of external energy. The processes which occurred spontaneously are flow of heat from cold. No, if that happened spontaneously, none of you would need a fridge. Me neither. Gas in a container contracting into one corner. Nope. Gas expanding to fill the available volume. Yes, this is a spontaneous process. अपने आप होता है ये चीज़. Burning carbon in oxygen to give carbon dioxide. ये भी spontaneous है. थोड़ा सा, all you need is, well, थोड़ा सा to reach the ignition temperature, but once you do that, अपने आप ही होता है. For an ideal gas, the work of reversible expansion under isothermal conditions, blah blah blah, दिया हुआ है, ठीक है. A sample containing 1 mole of an ideal gas is expanded isothermally and reversibly to 10 times of its original volume. Okay. In 2 separate experiments, ये होता है 300 और 600 Kelvin पे. सही option pick करना है. Work done at 600 Kelvin is 20 times. Why? Look at this. I mean, if you don't remember the actual expression, if the temperature is being doubled, the work done is going to be doubled. That's it, right? It's going to be doubled. So let's cross out these two. Delta U, yeah, because delta U is NCV delta T. If delta T is 0, isothermal लिखा था ना, तो delta U is 0. तो 3 and 4 on the 18th one, according to me. Yeah, बहुत simple लग रहा है यार thermo तो. Consider the following reaction between zinc and oxygen and choose the options out of the ones below. So this is related to that energy diagram मैंने पहले draw किया था. Options देखो ध्यान से. Enthalpy of this, right? मतलब what is that? This is product, right? This is reactant. Okay. So H versus Q. Q मतलब reaction quotient and H is enthalpy, right? Okay. So why have I drawn it like this? Because this is that minus 693.8, right? क्यों? इसका ये मतलब हुआ कि energy of products is lower than that of reactants, right? तभी तो, because energy is always conserved, you get this value of negative 693. Heat निकलती है, right? You're able to follow this? Okay. Now let's get back to see यहाँ पे चारों option में कहाँ पे this makes sense. Enthalpy of 2 moles of ZNO. Okay, that is product. Okay, product is 2 moles of ZNO is less than the total enthalpy of 2 moles of Zn and 1 mole of oxygen by, oh, perfect. This is exactly what we drew, right? Okay. Enthalpy of 2 moles is more. No, it's not more. If it was more, then this would be positive, but this is negative. Okay. That's the next idea, right? Energy is evolved, मतलब negative. Absorb, मतलब positive. लग रहा है एग्जाम्पलर थर्मो काफ़ी स्ट्रेट फॉरवर्ड है, मे बी बिकॉज इसमें ज़्यादा न्यूमेरिकल्स नहीं थे. न्यूमेरिकल ज़रूर हैं, बट हम लोग उसको नहीं करेंगे. शॉर्ट आंसर एंड लॉन्ग आंसर टाइप क्वेश्चंस हैं. यू कैन फिगर इट आउट. इफ़ यू वांट मी टू डू दैट, लीव कमेंट्स. Maybe I'll pick that up another time as well. अभी मैं सिर्फ MCQs देखना चाहता था and also assertion reason. So let's do that. ये पहला वाला सवाल क्या है? Combustion of all organic compounds is an exothermic reaction. Sure, this tracks, this works well. मेरे हिसाब से ये तो सही है. The enthalpy of all elements in the standard state is 0. ये भी सही है. But is this because of this? No. Combustion exothermic इसलिए होता है क्योंकि more heat is evolved as because the final products have a lower heat. You see that the lower H of products than H of reactants. We just did ऊपर बहुत चीज़ें की. तो ये दोनों statement सही है, but that's not the reasoning. Enthalpy of standard state being 0 is not the reason. Yeah, it's because some bonds are formed and the energy of those bonds formed is higher than that of जो तुमको चाहिए थे bonds break करने के लिए. That's it. That's the actual answer. Spontaneous process is an irreversible process and may be reversed. Okay, sounds good. Decrease in enthalpy is contributory factor for spontaneity. Yes, true. And also S, which is क्या बोलते हैं इसको, entropy, is also a contributing factor. Entropy increase is a contributing factor in spontaneity. Again, ये दोनों statements related नहीं है, दोनों सही हैं but unrelated. So इसमें इसका भी answer 2 हो गया. Last one here. Liquid crystallizes into a solid and is accompanied by decrease in entropy. बिल्कुल सही. In crystals, molecules organize in an ordered manner. Yes. ये वाला होगा. कारण भी सही है और करेक्ट एक्सप्लेनेशन भी है. क्यों? ऑर्डर मतलब डेल्टा एस नेगेटिव, राइट? इफ यू गेट मोर ऑर्डर्ड स्टेट, एंड दैट्स एग्जैक्टली व्हाट इज रिटन ओवर हियर. कॉज इफेक्ट. Cause is ordering, effect is, hey, entropy being reduced. Okay, that was it from me. If you want me to solve something specific, some questions, leave comments. And yeah, if you have doubts, come on to Discord. Link है description में. See you around.